Thank you everyone for joining yet another AWS Pretoria meetup. Today Luke is going to be talking to us. I'll leave it to him to introduce himself. Just a quick word, Luke recently joined the AWS Builder program, so big congratulations on that. Thank you. Luke, you can take it away from here.
Cool, thanks a lot. So my name is Lukonde Mwila, but as I've shown over there, a lot of people call me Luke, so you can call me that if you like. Some people do get away with calling me Skywalker as well. Good thing for you, I'm a Star Wars fan, so I don't mind it. Funny thing though is I don't like Luke Skywalker, or maybe let me rather say he's my least favorite Jedi. So that's the irony. But it would be very random for people to be calling me Obi, because Obi-Wan is actually my favorite Jedi. So yeah, I'm a software engineer. I'm working mostly in the cloud and DevOps space now. I work for Intellect and consult at Standard Bank. So yeah, I've been working quite a lot with AWS technologies, especially since the second half of last year would probably be the would be the time at which I started working a lot with it, especially the DevOps kind of tooling. Prior to that, it was mostly with the serverless technology, so a lot more on the application development side. But since the transition happened with more of cloud and DevOps, then even the tools and services that I work with has also changed. So I appreciate you guys making time to listen to me tonight. I definitely hope it'll be of huge benefit to you in some way. I love containerization technology, so I hope that was something that pulled some of you in as well. And the topic is, or rather the title, as it shows, Deploy Container and ECS Fargate behind API Gateway and NLB, is it's very specific. And so, I would be surprised if no one thought to themselves that, okay, so is this guy basically saying this is the only way you can ever do it if you want to do things in an optimal way or a secure way or a performant way? So I'm certainly not saying that, but I definitely hope that as we go through this, it will give you some ideas of how to think about securing your application, how to make it private, how to think of the best ways of accessibility to your container application as well. And for those who maybe haven't given much thought to accessibility, because sometimes when you're, if you're working with containers locally on your machine, you kind of get used to that. You don't really think too much about, okay, what is this actually going to look like when it goes live, and what would it look like at an enterprise level? What are the different pieces that would come around this? And so something that I really like to do is with certain subjects is to try and think of the journey from local machine development all the way through to what would it look like at enterprise scale? Like, how would you be able to actually be in a whiteboarding session of some sort and be able to propose a solution around these different pieces? So as I mentioned, I hope the containerization bit was a pull for some of you. It is definitely one of my favorite technologies. I love this meme on the left. I really feel like it's the easiest way to explain what Docker does. I just switched out that last line right at the bottom there. But yeah, it solved the whole problem of it works in my machine, then we'll ship your machine, and Docker was born. But I switched that last bit out to Amazon ECS specifically. And so containerization essentially helps out with the problems that you have with consistency and you thinking about, okay, the runtime environment for your application and all the underlying pieces from the operating system, making sure the dependencies are right. So it essentially helps with packaging everything that you need. For those of you that are very familiar with this and well versed in it, you might even be more proficient than I am. So just indulge me as I explain it, because I'm just trying to cater for those that might not be very familiar with this, or maybe they've got a basic level of it. And so like I said earlier, that's just the first step, right? So you've got your containerized application working on your machine, and it's great, whether it's for microservices or a single service. That is, if it's a backend service, or even if it's a front-end application that you want to be running. But then you start to think about, okay, how is this going to translate to when I actually deploy it? What's that going to look like? And so there are different platforms out there. And something that is super helpful is orchestration tools. So Amazon ECS is one of them. And as I've said over there, container orchestration automates the deployment, the management, scaling, and networking of containers, because you wouldn't really want to be able to manage all of that overhead when it comes to orchestrating your containerized applications at a large scale, at an enterprise level. It could be a pain. And so if there are great tools like Amazon ECS that can help with that, then rather make use of those things. I often say that Amazon ECS is almost like a response to Kubernetes, but it is an old and excellent tool, relatively old and excellent tool as well, and does very similar things to Kubernetes if you're familiar with Kubernetes. And so even in its architecture and the way that it is designed to help with orchestration of containers, it is very similar, but I'll touch more on that when we get to that particular piece. Okay, so I'd show, like I mentioned, in the subject there, or the subject heading or the title, there are a couple of other things that I mentioned in there. So I mentioned API Gateway and NLB, and those aren't really all of the things that we're actually going to be touching on. There are a couple of different components, and so it's kind of like an omelet, hence the picture over there. And so, it's all well and fine when you read about these different services. They were also in the description for the meetup invitation when it went out. And you could look at all of those things, and you might be thinking, all right, that's just it's a whole bunch of buzzwords that have been thrown in there, or are we just throwing all of these things out there to make the solution look fancy and funny? But that most certainly isn't the case, and we're going to delve into it deeper. But I'm just going to give a very brief overview of each one of these services or components that we'll actually be using that are forming part of what we actually want to be able to achieve. And so in this case, Elastic Container Registry, or ECR for short. Some of you may already be aware of this. It's essentially a Docker registry that is hosted by Amazon. It's fully managed, and it's a great service. So you can basically use it for storing all your container images, and you can create repositories in it. So that is where we're going to be storing our Docker images. So I've already got one created, and I've already got a Docker image that is stored in there. And I'll show you what that looks like in the console. And then aside from that, there's also going to be the networking piece, right? So our application, so because I've been, I use the word things like, how do we do this in a secure way? So that has to deal with our networking as well. So we're going to put it in an isolated network in a VPC. And so we're going to touch on that a little bit as well. I'll get into the details of that. And then we're also going to be using VPC endpoints. That'll make more sense when I explain the kind of VPC architecture that we're going to have, or networking infrastructure that we're going to be, approach that we're going to be taking. And then ECS is obviously the container management service that we're going to be using to run our Docker container applications. And then there's Fargate, which is essentially a serverless compute engine. And so this can be used if you want to eliminate the overhead of managing your EC2 instances. So you can obviously go with the approach of managed EC2 instances, of which you would then be handling that yourself or managing that yourself. But in this case, I don't want to be managing that. So that's why I'm going to be making use of Fargate. And then we're going to be using a network load balancer. Again, I'll touch on this a little bit later, but in case you're wondering, okay, why a network load balancer as opposed to an application load balancer? So an ALB is very good if you want to do smart or intelligent routing. And that's obviously something that you can also do in a container like an Nginx container. But in this case, so I'm just thinking of, okay, how do I get like rapid performance or optimal performance? And if you're looking for that, then NLB is a better option if you want, if that's what you're looking for in that particular case. If you want extreme performance for your TCP traffic, then an NLB is the way to go. Okay, so just so you know, you could actually make your network load balancer publicly exposed. That's if you're not already aware of that, and then you could actually just use that DNS name itself, and people can access your application through that, or your backend application in that kind of situation. Alternatively, you could place an API gateway in front of your VPC link, and You can use an API gateway as a managed service, and so that's what I'm going to be using as my doorway to my backend environment. And it's going to expose secure a RESTful API over an SSL, and we're also going to explore how to actually connect our API gateway to a network load balancer, and for that you need a VPC link. So a VPC link is a component that essentially enables us to create that private integration that connects our HTTP API route into an API gateway to the NLB in our VPC. Okay. So I just thought I'd let you know this entire setup, the infrastructure for all of these different components and how they fit together for this kind of solution, if I could call it that, is available on a public repository. So it was also shared on the particular meetup invite. It's on my GitHub, so feel free to get it. But the source code is all in Terraform, and I'm also making use of Terragrunt. So if you are familiar with that particular configuration language, then you can go ahead and clone the repo and make use of it. Feel free to make modifications. A friend of mine found a bug in the code. It wasn't working for him. And so yeah, I'm glad he pointed that out, and he sent a PR for that as well. So yeah, if you want to do that, you can please feel free to do it. So I will be making references to that source code. I'll be switching my screen to it a couple of times. If you're not, if you don't work with Terraform, and maybe instead for your infrastructure as code, you work with CloudFormation, for example, that's totally fine. When I make references to the source code, it'll just be so that I can give a little more detail about the different components or resources that we'll be setting up. I'm not going to be diving so deep into like showing you the folder structure for the application and the variables, etc. I don't want, because that's not the main purpose of this. I don't want us to get lost in that. It's more about the proposed solution, which obviously fits a very particular kind of use case. But like I said, this might be the use case that that would fit your kind of situation, or maybe it will help it'll help you rethink certain use cases that you might be dealing with. Okay, and then the other thing is also the walkthrough for this is also available on Medium, and so you can also make use of that on my Medium. I've got a post that has the entire walkthrough for this as well. So if you prefer to take a approach of reading it. Okay, so this over here, the bird's eye view, is going to be like the map for this entire presentation. I'm trying to take a little bit of a different approach for this one. And I'm going to keep referring back to this because this essentially contains all the different pieces that we're going to be making use of. And my hope is that as we cover ground, this will make more sense to you, and you'll see how everything fits together. And so this actually encompasses all the components or services that I mentioned, and we're going to be breaking it down bit by bit. And the first one that we're actually going to start with is we're going to start with our networking piece. And so for the networking piece, we're going to look at we're going to set up a VPC, the VPC that our container is actually going to be, our containerized applications are going to be running in. That's where our ECS is going to be deployed to. So that'll be the first thing that we actually look at. So I'll just give you a small tour of what that looks like in the Terraform code. Like I said, we're not going to dive in too deep with that. The important thing is to wrap our heads around the networking infrastructure that we have over there. And so you'll notice, as it shows in the diagram, that I don't have any public subnets. I've only got private subnets. And so, as you may know, subnets are essentially they're subdivisions of our VPC, and they've got particular address ranges based on the CIDR range that we selected for our VPC. And so you can deploy different resources like EC2 instances, RDSs in here. You can associate your load balancers with them as well. And this is where you can basically control whether or not instances are reachable over the internet. So in my case, because I don't have any public subnets, they are not reachable over the internet. I'm only using private subnets in my case. And so that obviously eliminates having an internet gateway. I don't need that in my particular case. And so What that does mean, though, is I'm going to do both VPC and VPC endpoints. What that does mean, though, obviously, is the resources that are deployed in these subnets are going to need to be able to communicate with different AWS services. And so there are VPC endpoints. And so the nice thing about VPC endpoints is they are essentially private links that communicate directly with AWS services. Just a little note, if you do end up using VPC endpoints, keep an eye on your billing because it can get interesting. But they are a very nifty tool if you're trying to go for this kind of security or privacy. Then you actually don't need to have a public subnet. The alternative, obviously, this isn't the only way of doing it. The alternative would be to have public subnets, and you would then have a NAT gateway in your public subnet so that anything in your private subnets would be able to then communicate with the internet via the NAT gateway via the internet gateway. Okay, so that's our VPC. So let me head over to the Terraform so you can see what that looks like. So like I said, this is going to be our map, so I'll just keep coming back to this. Okay. Alrighty, so if you don't understand entirely what's going on over here, that is fine. You can just pay attention to the comments over there with the hashtag. So what we're going to do is, like I said, we'll start with the VPC for our ECS Fargate, and then we'll actually move on to our ECS cluster, and then our ECS task definition and service. And after that, lastly, will be our API gateway and VPC link. So just keep thinking more around the solution itself as opposed to the syntax of this. And so what I'm doing is I start off by creating my actual VPC. And I enable DNS support because this is something that is required. And whether you can choose to tag your VPC, that's probably something you guys are familiar with. I think there was a recent meetup talk on VPCs. So this is probably something a lot of you, if you attended that talk or are competent with this, you'd probably already be aware of it. And so here's our networking setup. Because I'm trying to have as much privacy as possible, or to secure the accessibility to these to my containerized applications, I'm going to be running them in private subnets. And so that's what I'm setting up over here. And then in addition to that, this is wrong because I'm not running an application load balancer. So we can skip that, but just an important, this can actually still be helpful though. So in my case, I'm using a network load balancer, but in the case where if you want to use an application load balancer, you can go ahead and do that. And you can attach a security group to an application load balancer, but you can't attach a security group to a network load balancer. So that's just something important to note in case you're wondering that. And then over here, just setting up security groups for our ECS tasks. And those are short-lived tasks. I'll touch more on ECS tasks, so you don't have to worry too much about that. So in here, I'm also setting up I'm just setting up the security groups for this, setting up our ingress and egress for that. And you'll see the ports that I'm using for there are 443. And so you just want to make sure that you set this up correctly. As I mentioned, there are some, if you know Kubernetes, there are some similarities between that and ECS. And so some of these things over here will make more sense when I touch more on the ECS part and start breaking down what that actually entails. But yeah, over here, I'm just basically dealing with all the networking pieces to start with. Okay, and so then once we have our VPC, the other important part is our VPC endpoints. So as I mentioned, these are private links to, directly from any resources in our private subnets to other AWS services that it needs to make use of. And so the VPC endpoints that are being created are one to ECR, another one to CloudWatch. That's if you want to be able to be pushing logs from your applications through to CloudWatch, and S3. So S3 is required, as well as ECR. Now, if you were running a if you weren't going with Fargate and instead you went with a managed solution, you would need an additional VPC endpoint for ECS. But if you're going with Fargate, You don't have to worry about that. All of that is managed for you. And so this is essentially enabling our task definitions, which is going to consist of the particular URIs to our Docker images, which are stored in ECR. It's going to, so we want our tasks to be able to actually, our services to be able to reach out to ECR so that it can start up tasks based on that task definition, and the task definition has the URIs for those particular Docker images, which are stored in ECR. So put very simply, to enable communication from inside our private subnets to ECR, we need to have, this is the VPC endpoint that we set up. And in case you're wondering why S3, and so this is probably one of those gotchas where if you don't know it, then you could be stuck for a couple of hours. But thankfully, the AWS documentation does cover it. So the image layers for the container images are stored in S3, but you can't see them when you go there. So if you go looking for an S3 bucket with that, you won't be able to find it. But this is one of those things that happens under the hood. But you do need to create a VPC endpoint for it, and you get two types of VPC endpoints. There are VPC endpoints that are of interface type. So you can see here, VPC endpoint type interface. And you also have gateways. And so the S3 one is a gateway. So that's the one that you'd be setting up for that. So these two are the essential ones. And in the case that you were running managed nodes for your ECS solution, then you would have to make use of the additional VPC endpoints for ECS as well. Okay, cool. So let's just jump back to our solution. Okay, so that pretty much covers what's happening here with regards to our private subnet, which is living inside of our VPC. And again, this is going to be covered in detail shortly, but we're just making sure that there's going to be communication to S3 and to ECR so that we can be able to pull our images that our containers are actually going to be built from. And so, we're going to be turning our attention to ECS, but like I said, I just want to quickly make a note about the security groups. So we want to be able to allow inbound traffic to the application port for the VPC CIDR range, because our NLB will be forwarding incoming traffic to the instances. And we also want to allow communication between the VPC endpoint networking interfaces. So a VPC endpoint has an ENI or an elastic network interface, and we want to allow communication with resources in our VPC. And in the case of S3, we'll be using a gateway VPC endpoint, as I mentioned. And so our security groups are also going to be essentially the firewall for that kind of traffic as well. Okay. So now we can turn our attention to ECS. Let me come over here. I'm going to close those two. And so as we have over here, so ECS cluster. Okay. I'm just gonna talk a bit about this. So I'm not sure if any one of you might have used Elastic Beanstalk to run containerized applications on AWS. So it's often it's an often proposed solution if you want to quickly get your containerized applications up and running in the cloud. And Elastic Beanstalk is really cool. I've used it and it's super helpful. It sets up a whole lot of stuff under the hood as well. And one of the things that it actually sets up under the hood is ECS. So Elastic Beanstalk doesn't use something separate to ECS to get if you want to get your containerized applications running. Elastic Beanstalk is not exclusively for ECS. It's just it's a platform that you can use to run containerized applications. And so it's a really cool way if you want to remove even more management. So if you find that ECS Fargate doesn't do it for you, you feel like, okay, there's still, because you still get down ingrained in a couple of things if you're going to go with ECS. But if you want to alleviate all of that, and you really just want to focus on accelerating your application delivery, then you should go with Elastic Beanstalk, and it'll have all the nuts and bolts. But the point of me mentioning it is that Elastic Beanstalk is actually using Amazon ECS under the hood. And yeah, Amazon ECS is a lower level resource for dealing with the Docker container management. Okay, and so ECS actually has different components. So maybe what would actually be helpful here is to keep this diagram. So as I explained some of these things, maybe you can visualize it this way, because looking at that code might be a bit intimidating if you don't know Terraform. But so a cluster is a group of container instances, and so we're going to create our cluster, and then in addition to that, we're going to have our container instances, but our container instances are something that we're not going to worry about because we're opting to use Fargate, right? And so in our case, that's not something we're going to be managing, so we don't have to worry about that. But then you'll see over here that there are these items referred to as tasks. And so tasks are built off what is known as task definitions. And a task definition essentially describes how your Docker application's Docker images should be ran. So it's a JSON config file. Some people refer to it as a super Docker compose YAML file. So if you've seen what a Docker compose YAML file looks like your task definition looks a lot like that. And I will show you an example of that, because that's something that you can also define in Terraform. And then ECS also has a scheduler, which basically determines where a service or a one-off task will run your cluster by figuring out the most optimal instance for it to run on. Again, you don't need to worry about that because this is basically the brains of ECS, where it manages all of that stuff for you. And then you've got services, and a service is essentially like your long-running task. So ECS services enable you to run and maintain a specified number of instances of a task definition simultaneously. And so these tasks are just the end result of that task definition. And this is our service over here, which basically controls the number of tasks that you're going to have running. So it wouldn't necessarily be 2, even though I've put 2 over here split between our 2 private subnets. This is just an example to show you guys what that would look like. Okay. So let me come back over here. And so nope, that's not what we want. Collapse that and open ECS cluster. From a Terraform perspective, there's not much that's required to create your cluster. You just give it a name. So you can also do that in the console. The meaty stuff happens in here. So I'm going to open that for service and open this for task definition. And so over here, again, when you see this, if you haven't worked with Terraform, you can just keep thinking solution-wise, or what does this actually achieve? And so what we want to be able to do over here is we're basically attaching a specific task definition to our service. Sorry, Rihanna, I see like a couple of notifications coming up. Should I be reading the messages in the chat as well? I don't know if you guys typically ask the questions as it goes along.
No,
okay,
we will
cool.
like we'll ask them in the Q&A at the end of this session. So don't worry about it. I'll also stop you if there's anything urgent.
Okay, cool. Thanks. Sweet. Yeah, the virtual life. This is much easier with in person, because it's so funny right now. I'm just looking at this source code and hoping that guys on the other end are actually listening. But Rayan responded, so I know people are listening.
Yes,
cool. So cool. And so you'll see over here, I've specified my launch type. I'm going with Fargate. You'll see over here there's desired count. So that's essentially the number of tasks that you want to have running. So you can have a high number of that. You can also attach an autoscaler. An auto-scaling group for that as well to manage it, so that your tasks scale up and scale down depending on demand and load. And like I mentioned, you're going to attach a specific task definition, and we'll take a look at that. And we're associating our service with a particular cluster. And then in the networking configuration, we're associating our service with particular security groups, as well as the particular subnets. It doesn't have to be private subnets, but in this case it is. And then lastly would be configuration of the load balancer. And so for our load balancer, like I said, in our case, I'm setting up a network load balancer, which is going to be routing, which is going to target the entry point, in my case, it's just going to be a single application, a Node.js application, and I'll show you guys what that looks. It's essentially just a bare bone app that just has one path to the endpoint test, and that just gives a response of working. So there's not much to it. So you could go ahead and build your own Docker image in that sense as well. And so that's what's happening over here in our service. The task definition. So like I mentioned, this can essentially be a JSON config file, and your family would be like the name of the application, and then you would want to make sure you also have the correct role attached to it, and that role should have the relevant permissions to the different services that it needs to be able to communicate with. So obviously things like ECR and S3 as mentioned. And in the case where you want to be able to push logs to CloudWatch, for example, you'd also include those permissions. And then other important things over here, you can specify the kind of CPU and the memory as well. Those are things that would be very specific to a particular application. So I'm not going to get bogged down in those things. That will vary depending on what it is. It'll depend on your particular requirements. And so you'll notice that over here, there's just a bunch of variable names. So I will just still explain some of those things. And so obviously a very important one in this particular case, you'll see over here is image. And this would actually be the image URI. So if you guys are familiar with ECS or Elastic Beanstalk, then you'll know that in your whether it's the task definition, I think if you're using Elastic Beanstalk, if I remember correctly, the configuration file, which also looks like a Docker Compose YAML file, is saved as dockerrun.aws.json, and in there you can specify the images. So it can either be an ECR image, or it can actually be an image that is saved in Docker Hub. So those are the two registries that you can use to pull your images from, and it will manage that for you. You don't have to worry about that. And then port mappings. This works very similar to when you're setting up port mapping with your containers, even on your local machine. So you've got your host port and your container port, and this is where you would define that. So in the case where you have multiple applications, so you would add them all over here to this array, basically. And so just in case some of you have a question, so around this, in this particular example, it's designed to hit one backend service, which is a Node.js application. But some of you may be working in a space where you're dealing with lots of microservices. And so if you're wondering around that, so just it would be good to make use of something like you could either use an Nginx container, which you would also define here, and your Nginx container would then essentially be the single entry point, which then routes traffic to the different containers. Also, if you're thinking around like the network load balancer and how that's going to work with routing to different microservices, you can also make use of a service mesh, which is also cheaper, but there's programmatic overhead. AWS has a really cool service called App Mesh. If you guys haven't already heard of that, you could check that out. Another alternative is also to use a registry, and all of your microservices will essentially register with that. Again, that would be programmatic overhead, but I just thought to give you guys different alternatives to doing this, because this, like I said, this is one particular use case, and it may very well be likely that you're not just going to be running one container. You might be running who knows how many microservices or different types of containers. And then another approach would actually be to handle the routing on your API gateway and to run several network load balancers that all route traffic to the specific different containers. So that's just another approach that you could take over there. And then in case you're wondering, okay, so if I specify a particular image with its tag or with latest in this particular case, what happens if I update my Docker image in ECR? So let's say maybe you have a CI/CD pipeline, and in your CI/CD pipeline, you actually, you build your image and then you push it through to ECR, and now ECR has a new image or a new version of that particular image in the same repository. How is this task definition going to get updated? So there are two ways of doing that. There might actually be more. I know of two ways. So one way is you could use code deploy as part of your CI/CD pipeline. Code deploy integrates really nicely with ECS, and that will update your task definition for you. And so that way your task definition will contain it'll update it with the new image that you just pushed through to ECR, and that'll be how you can get your container, the latest version of your container up and running for that particular application. Alternatively, there is a command as well that you can run even just at code build. So if you didn't want to have the code deploy stage, then you could run that particular ECS command, which basically forces a deployment. And so after you've pushed your image to ECR, you can then force a deployment on ECS, and that will pull the latest image over there. Okay, cool. Let's go back to our map. Okay, so now that we've covered the ECS part, let's take a look at the network load balancer, which is actually going to be receiving traffic and forwarding the traffic through to our applications, right? And so I think I actually touched on this one a little bit, but let me show you what that looks like. Let me close these pieces over here and open that NLB service. Okay, and over here is our network load balancer, and we associate it with the particular subnet. So in my case, it's associated with the private subnets that I've set up. So I just have to pass those private subnet IDs in Terraform. But again, even if you do this in the console, that's essentially what you have to worry about. And then I set it up to be internal, so that means that it won't have a public DNS name, so you won't be able to hit it over the internet, or if you're trying to hit it through Postman, that won't be able to work because it's only accessible internally. And so that's just trying to achieve that same security that I mentioned that we're going for. And then a very important piece which links with our with ECS, you might have seen in the service. Let me just quickly open that again. You'll see over here that we need to associate our load balancer configuration in our ECS service with a particular target group, and so that's where our network load balancer forwards traffic to. And so you'd create your target group and set it up. You can see over here I've called mine NLB-PTA meetup exclusively for you guys because you're special. And so our target group is associated with a particular VPC. You specify the networking protocol as well, and this is what's going to receive traffic from the NLB. And it's going to be, so we also set up our listener over here, redirect all traffic from the NLB to the target group. So this is just more of like a Terraform piece, but it would look differently when you're setting it up in the console. But essentially what we're setting up here is NLB receives traffic, forward traffic to this particular target group. You define the networking, the network protocol as well. And that particular target group that you set up is what you would associate with your ECS service, and that's how that flow happens. And you would use the same protocol for the container that you're going to be running. So if your container is running on port 8080, you want to make sure that your listener is then forwarding traffic, or your NLB is forwarding traffic to that particular target on that port, so that it's getting to the right place. Okay. Back here. Okay. By the way, I'll show what these different pieces look like in the console as well. So I hope this isn't so if that's the more exciting part that you're looking forward to, then I've saved the best for last in that sense. Or maybe you're thinking, does this thing actually work? So in that sense, maybe that's the best bit. So I'll show you that right at the end. And so we've pretty much covered this space over here, as well as touched on these two pieces, what they're for essentially. And then the last step is actually our API gateway and our VPC link. And so this would look different in a case where if you were running let's say a front-end application in a container, then you wouldn't really need to worry too much about some of the same kind of security, or you could, depending on whatever your use case is. But in this case, because it is a back-end environment, you're obviously thinking about, okay, who's authenticated to actually access that back-end environment? So, I've basically been demonstrating a way to create a closed network environment, still making it optimal in terms of performance with the network load balance over there, in terms of accessibility and managing the traffic. for our containerized application, and now we want to actually find a way of securely exposing this. And so one of the ways of doing the way that we do that is to create this private link with our API gateway with the network load balancer, which is running inside a specific VPC. And the way to do that is with a private link, and that will set up a service endpoint over here, as you can see. I'll show you that in the console as well. And that VPC link essentially creates that private link to the network load balancer. And the API gateway gives you a lot of tools, if I could say, to configure things the way you want to manage your doorway to the backend environment. So for example, something that I haven't demonstrated here, but would be really cool as well, is if you've worked with Cognito, which is AWS's identity management service. So it could be that your application is making use of Cognito, and every time that a user authenticates with Cognito and receives a JWT, when traffic is then forwarded from some kind of client to the API gateway with a JWT token attached to it, the API gateway, if you configure it with Cognito, will essentially check to see, is this person who they say they are in Cognito? And that also just adds some additional security, because in this particular case, I haven't configured that with Cognito, but that would be a really cool piece to add as well. And so you could basically manage who every user that essentially ends up accessing your backend environment over here at that point to see whether they actually are a user in Cognito. So let's see what that looks like. In here, I'm going to close the NLB and the service, or maybe let's keep the NLB open and open the folder API Gateway, and VPC link. And if you've ever created a VPC link, you will know that it takes some sweet time. So you could step away from your machine when you're doing that because it takes quite a while. And so there's a lot of there are a lot of resources that are being set up over here, and like I mentioned, I don't want us to get too bogged down in that, so I will essentially just tell you what we're doing over here. We're setting up a RESTful API for our backend environment, and you can define the different paths in here. In my particular case, if you want, what you could do is you could specify over here HTTP method to accept absolutely anything, and so you could say any over there, and this is where you would define the authorization. So in my case, I've said none, not very secure. This is where you would also configure Cognito as well, and then I'm setting up. This is where I set up the API integration with the network load balancer, and so this is where I'm configuring it to basically say, hey, you should forward traffic to this particular endpoint. And the connection type is what we're defining over here. You can see the connection type is with a VPC link. And so the VPC link is what we're creating over here. The resource itself is very tiny, but do not be fooled. It is a beast. It takes a while to set up. Okay, so now let's see what this stuff actually looks like in the console. So over here, we're in ECS, my cluster, AWS-PTA meetup, dev cluster, mouthful. And then here's our service. And so you'll see I set up a desired task of 1, so it will make sure, our service will make sure that there's always at least 1 task running. So if I click on that, you'll see over here details, so that you can see actually the details for the load balancing. You'll see the container port is 8080, so that's the port that my container is running on. That's something that I define in the application itself, and then in the Docker image, you would just expose port 8080 so Docker knows which port the container is going to be listening on. And this is the target group for the NLB, something that I pointed out to you guys as well. And then you'll see over here, we've got the security group that's attached to that. Let's take a look at the tasks. So because I'm only running 1, you'll see over here, this is our task, and it's based on this particular task definition, JSON. And over there, you'll see the image, and that's the particular image that I'm running. It's an Express, Node.js Express application. It's a very basic one. It just has 1 path, like I said, to test, and that test returns a response of working. Okay, and so that's what we have over there. I have not set up any auto scaling, as you can see over here, but that would be something that would be very good to manage your tasks, to be able to increase the desired count over there, etc. Okay, and so something else. Let's go back to our roadmap. So it's ECS. Let's take a look at our NLB that has been set up. Now this is the target group. Our NLB should be here. So the description. It'd be very funny if my session expires and then I have to start logging in again. I just have to select it. Okay, there we go. NLB AWS-PTA meetup. Just so you can see that over there. This is our network load balancer. This is the DNS name, but it is not public, so we're not able to hit this. And here we go to listeners, and listening on port 8080. And so come to our target group. You can check and go to monitoring over there. Let's take a few minutes. You can manage the monitoring over here and targets as well. And you can see over there IP address, the port. You can see the associated AZ. Sorry about that. And you can see the status is healthy. Okay. All right. And so back to our map. And let's take a look at the VPC endpoints. I'm going to come to VPC. So this is my particular VPC. You can see the CIDR range that I selected for this. You can see the endpoints that have been created. I think I probably have a couple of VPC endpoints that are going to be inside here. Or not. Okay, cool. All right. Looks like I'm learning to behave and actually destroy stuff when I'm not using it. That's what happens when you get big bills because of leaving stuff on. So you can see over here, these are the 3 VPC endpoints that we needed. So this is the one so that our tasks can actually be able to get started up, because they're able to reach out from within the private subnets to the ECR to pull the necessary images. CloudWatch, so I can push through application logs. In my case, because I said it's such a simple application, I don't think I'm even logging anything, because that's not really the focus, but just to show you how to set it up. And then S3 obviously is something that is required. It's also a VPC endpoint, but of type gateway, because they're the image layers for the container images. AWS stores those in S3, even though it's something that you don't see. Okay, and then the last thing to show you would be API gateway. Okay, so let's step back. Here's the roadmap. So it's this one over here, AWS-PTA meetup dev. And I'm going to go to stages. Let's just show you this. So just in case you want to see what this actually looks like. And so it's accepting any types of requests, and then you'll see that there's no authentication, and it's actually just proxying those requests. That's essentially what API Gateway is doing for us, and then it proxies those requests through to our network load balancer. As you can see over here, the endpoint URL is directed to our NLB. And if you go to stages, dev env proxy gets, and so you can see over there, we've got our invoke our URL for application, which is the same one that is actually over here. I've already got it open, and so you'll see I've created one particular path which is called test, and I'm just going to refresh that so you guys can see that it is actually working. And that is essentially it in a nutshell. I certainly hope that it was relatively clear with this roadmap, and then just showing you what the different resources look like in Terraform, as well as what the output is in the console when you can see the different pieces over there. And yeah, I'm going to stop sharing now.
Thank you, Luke. That was quite insightful. So we are doing a lucky draw in a few minutes. I'm going to share the link over there, and I'm going to also share my screen and exit this event mode. So please feel free to ask your questions. You can unmute yourself and ask them. I did note a few of them down. So I'm going to go first. We have one from Andre that asked, how would you handle non-public Docker Hub container images? Luke, I think you're muted again. You could just unmute yourself and share your video.
Yeah, let me do that. Cool. Sorry, could you please repeat the question, Rian?
So Andre asked, how would you handle non-public Docker Hub container images?
Non-public Docker images. A Docker Hub.
Yes, Docker Hub images. Andre, you can always unmute yourself and maybe ask more specifically.
Can you guys hear me?
Yes.
Oh, perfect. Okay, so you mentioned that instead of pulling images from ECR, we can pull images from Docker Hub. But if you've got a private repo on Docker Hub, it's not just going to automatically pull that, and you need to put some sort of credentials or secrets. How would you handle that in the particular architecture that you've taken us through?
Yeah. So you can still actually use VPC endpoints. So this isn't something I've set up myself, but I have read up on it. So you can still use VPC endpoints, and with that VPC endpoint, you can essentially specify that it is not for an AWS service, but it's to, and then you can basically in there define that it would be to Docker Hub. So you'd probably just have to explore how to authenticate with your particular Docker Hub account. But just so you know, that's how you would go about it. You'd still use a VPC endpoint to integrate with Docker Hub.
Awesome,
okay, well,
thanks.
I have one. So I was wondering, so can those containers talk to the internet? I didn't really see any routes going to the internet, or is it completely isolated?
Sorry, please repeat that, Rian. Was it that can't see any routes going to the internet?
Yes. Is that setup completely isolated, so nothing can leave that VPC?
Yes, that was deliberate. That was the purpose, to basically create that very isolated shell, or that kind of secure kind of network, so that it's a way of getting rid of ever having the risk of traffic ever hitting your instances.
Yes, so I can see that you are working in a banking environment, because I had the same once, and yes, like nothing can leave that VPC. Everything must have a VPC endpoint, basically an IP, so that you can see where traffic flows in your flow logs, and it just gets more fun from there on out.
Yeah.
So another one maybe.
Sorry,
I
just
think you mentioned it quickly.
VPC flow logs those are important.
Yeah. So
I've
why
got another
did you
question.
use?
After you're done, sorry, Rehan. So after you're done, I'll ask that question. Can I go ahead?
No, you can go.
Oh, okay, cool, thanks. So look, on the network diagram, or the architectural diagram that you set up, how easy is it to sort of migrate the ECS Fargate solution to probably like an EKS solution, since everything's running on containers and you're pulling from technically the same place, and you're going to have this EKS cluster running from within the private subnet and VPC? Is it an easy migration to, instead of fall off to ECS Fargate, or instead of pushing to ECS Fargate, you just push it straight to EKS from within the same VPC, so to speak?
Yeah. So if you're competent with Kubernetes, then the switch up should be fine. The migration rather. Sure, if you've got your images in ECR, that's not really something you wouldn't really worry about that. That'll be fine. I think even in terms of still going for the whole approach of API gateway, private link, NLB, that is fine. I think what you have to wrap your head around with is the EKS architecture. That's what is going to be different. So if that's something that you've already got on lock in terms of Kubernetes, and then just understanding how that's going to work in an EKS setup, then you should be fine. But if you're not competent with Kubernetes, then that's when it might be a bit, the migration might be a bit tricky. And if that answers your question?
Yeah, that does. Thanks.
Cool. Sure.
So Luke, you mentioned that VPC endpoints can be quite expensive. It sounded like you had quite an interesting story behind that.
Yeah. So a friend of mine, Calvin, Calvin, are you on the call? Just out of curiosity, he said he was going to join.
Yeah, man.
So, okay, cool. So Calvin's is a good friend of mine, and we work together. And so I was bragging to him, telling him I got AWS credits, man, and so I don't need to worry about shutting down stuff. Like I was bragging to him. I'm like, I have EKS running and I have ECS running, man. So I'm like, I can go to sleep chilled. And I was in his face about it. And then I got smacked with a bill that basically almost depleted. It just about depleted my services, and I was like panicking, and I started shutting down stuff. And I went to review the billing. This is not smart. Make sure you have your your budget reports in check, and that they're actually sending alerts to you and stuff. This was just me being cocky. When I'm reviewing the budget, I'm looking at the costs of the different services. And so in my head, I was just thinking around the costs of the EC2 instances, ECS and EKS, because they're managed control planes in both of them. And I had no idea what the costs would be around VPC endpoints. And so I'm seeing the costs for VPC because VPC endpoints fall under that category. And I go to that and I'm like, since when did a VPC cost so much? And then I break it down. And I see the costs of the traffic on the VPC endpoints. I'm like, oh, okay. All right. So guys, if you're gonna go with VPC endpoints, just be on the lookout for that. The smart thing is just make sure if you're not using stuff, shut it down. Just shut it down.
Always good advice, Luke.
Yeah.
Jason Nichols here. So how expensive was too expensive?
So too expensive for me was almost depleted the credits that I had. Because
I understand.
Yeah.
So a VPC endpoint costs 1 American cents per hour. So you're paying for the ENI. So it depends how many availability zones you're running it against. So that's about $7 a month for the VPC endpoint. And then, as you mentioned, there are two types. So there's an interface endpoint and a gateway endpoint.
Yeah.
And the gateway endpoint is at no charge. So gateway endpoints run against S3 and they run against DynamoDB. VPC link, on the other hand, is different to a VPC endpoint. Just for the pricing clarification.
Sure thing. Yeah, sure thing.
Do you pay for traffic on those endpoints? Is that maybe why you saw such a big bill? Because it's putting the Docker images, which can be quite big, over that endpoint every time.
Yeah, because remember, like the tasks are starting over and over again. And so I was running both EKS and ECS. And so those are short-lived, or like they're ephemeral objects. So the pulling is happening over and over again. So I've been running them over a period of time.
Yeah, so that's where you could definitely get cost. So it's about 1 cent a gig as well. So you're paying 1 cent an hour, and then you're paying 1 cent a gig. Obviously, it depends on the region.
Yeah.
But that's where the costs come from.
Okay.
A really cool presentation, Luke. I enjoyed that. That was really awesome.
I'm glad it was helpful, man.
Another question, sorry, from my side, in regards to the Terraform sort of code that you set up. If you run a Terraform destroy with this, will it leave anything left over from what it created, or is it just gonna destroy everything? So if I go through it and do it and apply and spin up all these services, when I do a destroy, is it gonna destroy other things or everything, or how is it gonna work? Is it gonna, because I've done a destroy before and it left some resources as well. I didn't delete everything, so that was a bit weird.
Yeah, no. So this is so I've set it up in such a way that it's going to destroy everything related to your net. So basically, everything you see in that diagram will be destroyed. And if you were to run a Terraform apply, everything in that diagram will get set up. The only things that aren't set up that are in that diagram in my Terraform source code are, like I said, the S3 bucket, because that's happening under the hood. AWS basically stores the container image layers in there, so you don't have to worry about that. You just need to set up the VPC endpoint to there. So that's not, you don't set up that bucket. I already have, and again, ECR is a managed service, so you're not going to be creating that, but you would have, you can create your repositories and push images in there. That shouldn't be too costly, I think, if I remember correct. Yeah, so everything else, well, yeah, if you run apply, it will set it up. If you run destroy, it'll bring it all down. So yeah, you can, but just no harm in double checking. No harm in double checking once you've run your Terraform destroy.
Anything else? Maybe just have one last one. I know we are short on time, but I see this one from Andre. He asked, how do you store your Terraform data?
How do I store Terraform data?
Yeah, basically, how do you manage that so that you can have multiple guys running the Terraform command without it having to rebuild the local cache every time?
Just so I understand your question, do you, sorry, was someone speaking?
I was going to say, I think you're referring to the Terraform state.
Oh, okay. Yes. Thanks for that. So, yeah. So that relates to the concept of states, which will basically persist the state of the infrastructure that you've set up. So you can set up a remote backend for that, which will contain the state for your the cloud infrastructure that you've built. So you can use you can create an S3 bucket for that. So that's a whole chicken and egg thing. So you could create that beforehand manually, create your S3 bucket, or you could do it through the AWS CLI, and that will essentially persist your state. So once you have it spun up, you can modify it, and anytime you're running any Terraform commands, it will be able to check to see what is the existing state and what is the desired state. Desired state being any changes that you want to make to that. I hope that does that answer your question?
So I was into the chicken and egg situation some time ago, and I was wondering how you guys manage it, because eventually just did like you did with the S3 bucket created by hand by a console, and just ignore it. Just, hey, that's life. Just accept it and go on.
Yeah, no, same. We also just set it. We always start off with setting up the bucket manually, as well as DynamoDB table for the state locking.
Yeah,
so
the locking table.
Yeah.
Cool. Thanks a lot.
Sure, man.
Great presentation.
Thanks a lot, man. I'm glad it was helpful.
Okay, I think that's it then.